It is my pleasure to welcome Dr. Sarah Dreier, who is in political science, where I didn't realize how much AI research is actually going on in political science. But Professor Dreier has actually had involvement with the Allen Institute and done all kinds of interesting work in, I think, one of our first large language model talks, maybe.
All right.
And so I will hand this over to Sarah, and then we'll go through our talks and get into the session.
Okay, thank you, Melanie. And thank you, Sonia, for that incredible presentation. I want to go to law school, but I don't want to follow you talk. It's a tough act to follow. Okay, so I am an accidental arrival to the space of AI and AI research. I want to say a little bit about how I got here, which gives some context for the research that I'll present today. And as a caveat, the research I'm presenting today is a few years old at this point, which we've learned from the talks this morning that the world has changed, the world of AI has changed dramatically and rapidly since then. So this talk might show a little bit of its age, but I'm not quite ready to present the sort of new projects that I'm working on with some of my colleagues in Washington. So ask me back again next year. Okay, I am trained as a political scientist from the University of Washington. And it was shortly after the 2016 US presidential election. And we in political science were trying to make sense of the implications of that election for democratic institutions. So on that score, not much has changed in the last 8 years. Anyway, as part of that project, a colleague and I decided that we wanted to investigate how government officials in liberal democracies talked about and justified their decisions to violate the rights of targeted citizens or residents. So how do government officials rationalize policies like detaining political opponents, citizens, or immigrants without trial? So my colleague went to the United Kingdom's collection of National Archives and photographed 8,000 pages of the British Prime Minister's correspondences during the early years of the so-called Troubles in Northern Ireland. And I think I have someone from Ireland here who will be able to fact check me on all of those points. So this was data between 1969 and 1973. At this time, executives in the government debated and ultimately decided to adopt internment without trial against those suspected of affiliation with the Irish Republican Army. So these documents that we collected were things like declassified meeting minutes from meetings in which these major policy decisions were discussed, deliberated, and finally decided. And also drafts of telegrams to people like US President Nixon, which we can then compare to the final sent telegrams. Okay, now we had a problem. We needed to read these 8,000 pages, which seemed like an arduous and honestly boring task. And we also needed a way to sort of make a broad appeal to potential donors who wanted to fund this research. So we partnered with Professor Noah Smith at the University of Washington's Paul Allen School of Computer Science and Engineering. And for about 2.5 years, I worked with his lab, his natural language processing lab, on a variety of research topics, including this effort to evaluate how well a BERT-based transformer model would handle our archive texts. And our specific task was to train Roberta to identify and classify our concept of interest, which was justifications for internment without trial that government officials offered in their internal conversations with one another. Now, of course, if successful, this task would alleviate the time a future researcher could spend manually reviewing the material. There are a couple of reasons why this project offered particularly interesting NLP questions, including the fact that this was an extremely small corpus of text and data, 8,000 pages max. So very, very small in the world of natural language processing. It was painfully poorly digitized. There were relatively few true positives. So of the 65,000 sentences in our corpus, roughly 2,000 constituted what we considered a justification for internment. So really, really small number of true positives. We had many examples without a clear keyword signal. So 2 sentences of interest saying similar things but using different words to say them. And the fact that our text collection was fundamentally different from the text that computer scientists typically use. Both different from the texts that are typically used to pre-train these models and from the texts that computer scientists use to sort of test and evaluate and advance the models. And this was one of the most compelling questions for all of us, which was how well would a large language model that is trained on digitized web text from news and Wikipedia and social media and digitized books and legal contracts, etc. So how well would a large language model pre-trained on this text perform on a very, very different and idiosyncratic collection of text? So text generated by British executives and security bureaucrats in the 1970s. Now before we get into our results, I want to step back and explain, earlier today we heard about transformers and the sort of revolutionary component that they played in LLMs. I'm going to take a step back and explain another component of these transformer-based large language models, which is the word vector. And here I really apologize to my experts in the room. This is going to be painfully dumbed down and repetitive for you, but I am speaking to those in the audience who are less familiar with these concepts. So essentially, large language models are pre-trained on these huge swaths of available web text, not all available web text, as I think you made the point earlier. And they take this text and they build a numeric vector representation of every word that appears in that collection. And the word vectors are designed to capture that word's semantic meaning and its syntactic use in the collection, so grammatically how it's used. And these word vectors allow the models to predict, classify, and generate text. Okay, but what happens when a word has multiple meanings? So I have an example of the word piece IRA. So I'll hazard a guess that the word vector for IRA in our modern LLMs that are trained or pre-trained by Facebook in 2019 disproportionately cater to represent individual retirement accounts. But of course, in our data, it means something entirely different. IRA in our data refers exclusively to the Irish Republican Army. So part of the LLM revolution that happened in the last decade or so was the development of contextualized word vectors, which allowed models to adapt the pre-trained word vector according to how a given word is used in a given text collection. And this is one of those advancements that has allowed us to take a large language model that was trained in the 2019 and apply it to a collection from the 1970s. Okay, so what did we find? We found that despite these considerable and unique challenges that our corpus represented, we do show that large language models outperform more conventional automated approaches to classifying text, and that they can correctly classify even segments of relevant text that lack strong keyword signals and those that represent infrequently occurring categories. So this was a category that we did not observe often. This was a sort of deterrence argument that says, tell Wilson, Prime Minister Wilson, that if there had been more interned sooner, there would be less bombs and bloodshed today. So this was one of our categories that occurred the most infrequently, but the model still effectively classifies that. We also find, so the other question is now, what does this mean for using large language model classification instead of manually annotated text in practice? So what we find is that in our case, we could adjust the model parameters, and in particular, we could relax our precision to recall virtually all true positive cases of our concept of interest, along, of course, with retrieving a higher level of false positives. From here, a researcher could manually code only those sentences that the model recalls, rather than all of the sentences in the corpus. So in our case, this would reduce the researcher's manual coding burden by 76% relative to if she were to code the entire corpus. And we believe that this is a really promising outcome. But I do want to stress that there are some roles that only a human can perform. For example, without qualitatively reviewing these data, I could train a large language model to identify and classify government justifications for internment, count which justifications occur most frequently, and then conclude that these justification categories that occurred the most frequently were the prevailing motivations behind these decisions to violate rights. But simply counting how frequently a category appears in our data could yield very misleading results. This is because the model would fail to account for influential ideas that have occurred infrequently within the data, but were really important. For example, it could fail to account for influential ideas that were explicitly edited out of the record and removed from future conversations. So in this case, we see that certain leaders wanted to adopt internment for political gain. And as the government prepared their public explanations for internment, they deleted these sort of unsavory motivations, and we can see them literally being edited out, and replaced those motivations with more motivations that were more directly aligned with established standards for violating human rights during emergencies. My point is this. Large language models demonstrate considerable improvement gains, even among a uniquely challenging corpus. In order to practically use these classification outputs, we needed to target manual annotation. So we needed to conduct manual annotation beyond the annotation that's required for training a model to begin with. And third, there are important components of knowledge generation that absolutely require human intuition. How am I doing for time?
2 minutes left.
2 minutes left. Okay, should I keep going? Okay, I'm just going to give a really, really pathetically short snapshot of another component of the research that I've done with this University of Washington team, and that is beginning to address an additional source of bias within large language models. So we know that one source of bias comes from the fact that models are pre-trained on massive amounts of human-generated data and therefore biased text. We know that biases in human annotation at the training process that are then used to train models can also lead to biased outcomes. But one thing that hasn't been particularly well addressed is whether there's bias in the text selected to pre-train models to begin with, which can then in turn contribute to the biases in the human text. So one overlooked source of bias is introduced by the so-called quality filters that determine what web-based text is used to pre-train models in the first place. So we sought to evaluate whether certain voices or authors from certain social positions were more likely to be flagged as high quality and therefore included in the pre-training process, and whether there were certain voices that were more likely to be filtered out for being low quality. And what we found are that quality filters are more likely to filter in text that appears in text that's been generated in high-income and urban high school newspapers relative to text from lower-income high school newspapers. And again, I want to stress that these filters are supposed to identify usable text, not like highbrow or perfect language. We also, so what we did was we just threw a bunch of different kinds of text at these quality filters to figure out which pieces of text were more likely to be considered high quality and used for the pre-training process. So we also found that among Pulitzer Prize-winning text, nonfiction was more likely to be included as usable and high quality relative to poetry and drama. And we found that among TOEFL exam responses, the topic of the essay prompt was more predictive than the essay's resulting human-given score of whether or not the text would be considered as high quality. So these examples just demonstrate that the so-called quality filters that are used to pick what text on the internet is used to train these models offers some kind of preference for certain language ideologies and excludes others. So this is even though these models are then used to classify and generate language according to how humans actually use this language, not according to what would be acceptable in the New York Times or a dissertation piece of work. So the takeaway here is that the field should give greater attention to what language is selected for training to begin with. And if our quality filters are systematically filtering out text generated by authors with non-random characteristics, as this research suggests, then the resulting models will reflect, reinforce, and amplify certain language ideologies over others, resulting both in underperformance and perpetuated social biases. Thank you very much.
Excellent. So let's see if we can get one or two questions for Sarah, and we'll have Abby come on up and sit up here. Yeah.
About bias in terms of different viewpoints that may not be represented. Do you think in terms of how many people might hold such a view, which would be one way that, there's obviously big skews of people holding common views, and then there's very rare but perhaps valuable views. What would non-bias look like? It seems that any representation you choose will either have to make a decision about a more common view, or to maybe overrepresent fringe voices, to even include some of them because they could be so small statistically. What's your thoughts on that?
So I think that it's the computer scientists that I've had this conversation with have said we want to move away from thinking about fringe versus widely held perspectives and think more in terms of just what perspectives are disproportionately represented in the data. So for example, one of the things that we looked at in this last research was Wikipedia text. And Wikipedia text is disproportionately generated by men and disproportionately generated by people living in English-speaking countries. That doesn't mean that men hold a more common perspective than women, and it doesn't mean that people in the English-speaking world are the predominant perspective and people in the non-English-speaking world are not the predominant perspective. It just means that these minority population are overly represented in the data. And the concern is that when you've got certain social inequalities that are disproportionately letting certain voices be represented in the model, in the text that's being used to train the models, then we get biases in the outcomes, and also misperceptions about who represents a majority perspective and who represents a minority perspective. Does that answer your question?
This is a tricky question.
Yeah.
I guess, could you give me, like, if we're to say, we often identify bias, well, that's this bad thing, but is it a gap that can even be closed? Because
Right.
they might have very different models of what,
So I don't think, and again, I don't think that people are seeking to close the bias gap. I think people are seeking to make sure that we have as many biased perspectives represented as possible. And some of the colleagues that I work with, at University of Washington and the Allen Institute, for example, are starting to think about providing models that give the researcher more knowledge and more discretion to be able to choose what kinds of voices they want their models trained on. So it's about giving, providing as much voices as possible in order to remove the sort of skewed bias toward, white men living in English-speaking parts of the world, like we have in the sort of Wikipedia example. And it's also about giving the researcher the discretion to be able to actually have a transparent understanding about what text was used to train the models they're using, and then to sort of manage them according to their research objectives. So giving the researcher the ability to sort of nimbly use the models that are going to be best serving them. And I'll just point out that if there's one thing that's probably true of most, if not all, language models that all of us are using, is that they are profoundly lacking in transparency. Nobody knows what's going into these models.
Very important note to end on.